Hello everyone, this is Rajoshi, and today is the day 3 where we are going to solve our problem, which is contains duplicate. It's a very popular problem based on the concepts of array and hash table. Let's start from the solving the problem. So first of all, we have a description that any value appears twice. We need to return the value. So we have given an integer array and we need to return true, a boolean field, if any value appears at least twice, that means more than one. And we need to return false if all the elements in the array is distinct. And this problem is asked by these companies. So let me tell you an example in which we are given an array containing 5 elements. First one is 3, second one is 1, third one is 4, fourth one is again 1, fifth one is 5. So 1 is appearing twice, so we need to return 1. Uh, so we need to return true because 1 is appearing twice. So now let's start the animation. Let's start the visualization how we can solve this problem. So we need to compare it using the two-pointer approach. So where ARR of 0, that is the first element, is 3 and ARR of 1 equals to 1. Both are different elements where I and j are pointing these first and second element of the array. Then in the next step, ARR of 0 is still 3 and ARR of 2 is equals to I. That means we are incrementing the pointer j while the I is still same for the first iteration. That means we need to use here nested loops, where the first loop will be containing the value of I and the second loop will contain the value of j. So we are incrementing the value of j, then it checks the ARR of 2, that is the current value of this array is 4. These are different. So we are going to moving on. Then again, the value of j gets increment. These values are still different, so we are doing nothing here. The same thing is happening. But in the next step, so we are incrementing the value of I equals to I plus 1. So now I is pointing to this value. That means the ARR of 1. And now we are going to check for the same thing. So ARR of 1 equals to 1 and ARR of 2 equals to 4, the different elements. So we need to return nothing. Yes, now it's the point where our base case got hit. So we are comparing ARR of 1, which returns us 1, and ARR of 3, the value of the j pointer returns it. So the ARR of 3 equals to 1. So these two elements are same. So that's why we can say that duplicate element is found. So we need to return true, else we need to return false. So how we are going to solve this problem? So first of all, we need to write a for loop. We need to use a distinct two nested arrays. So first of all will be, so for I equals to I will be equals to 0 to I will be equals to n minus 2. Why n minus 2? Because we are targeting the second last element of the array for the outer loop. And in the second case, it will be for j equals to I plus 1 to j will be equals to n minus 1. That means the last element of the array. Then we have to check for a condition, that is if ARR of I is equals to ARR of j, then we need to return false. We need to return true. That means the array contains duplicate element. Else we need to return false. So this will be our algorithm. Let me run it once. The AI is running and it's taking a little bit of time. Yes, our problem is solved using the two-pointer approach where we are using two nested arrays. But the problem is here the time complexity is big of n square as we are using two nested arrays, and in the worst case the both array needs to traverse the entire array for the two times. So the worst case time complexity for this approach will be big of n square. But we still have a best optimized approach, which is using set. So that will give us a time complexity bigger of n. But as we are using set, so we have to maintain a space complexity of bigger of n. But most of the cases, we prioritize the time complexity much more than the space complexity. So it will be a better approach for us. So let's see that approach. Okay, start over. Let me start over. Right. Will be something like this. So I think I need to reload it once. Yes, this is the optimized approach. So from this approach, what we can do is we can initialize a set of integers, and we need to put all those elements of the array into the set. And as we know that a set contains only and only the unique elements, then whenever we find that the set contains a duplicate element, then the length of the set will be uh, much more higher. So that will be the condition where our base case get hit. So let me start the animation again. So first of all, we can keep the set of values seen so far. So before adding ask, is the value is already exist in set, that takes big of one time. Then, so first of all, we have initialized a set. Then we are traversing through the array. If the value is present in the array, that is, if x is seen, then we are just returning true. Else, we are adding the uh, element to the array. Right. So first of all, we are adding 3. Then we are adding 1. Then we are adding 4. Then in the fourth iteration, 1 is already exist in the array, but we are trying to check for the this element that ARR of 3, which is 1, is already exist in the set. So we are going to return true. So this will be our algorithm. So let me start it. So scene, it will be our set. So let me initialize it. And then we need to fill up all those, fill up the set with the value of array. So for x in scene, and we have to check for a condition that if x is present, that means if x is present in scene, then we need to return true. Else, we need to just scene dot, we need to add the value that is x. And in the last case, we need to return false. So this will be our straightforward algorithm. Our AI is running. Okay, we are facing a problem that is the loop is iterating over scene. Okay, so it will be ARR, which means okay. And if X in scene is always be false, so scene, so you need to add elements from ARR, right? Right, I did my answer. So it will be, I made a mistake. So it will be our ARR. Now let's try to evaluate it once again. Yes, our problem got solved in big O of n time and space complexity. Now let me solve the problem in our lead code. So this is the same problem which is present in our lead code, which is the problem number 217. And we have implemented the second approach here because the first approach will cost us a big O of n square time complexity, where we have initialized a set of integers using the HashSet class. And we are used for each loop where we are iterating over the array. Here it is named as nums, and we are just adding it. So we have used a slightly different approach because I felt it will be a little good to be understand. And then we are just returning a set.size is less than num.length. That means as we are putting all the element in the array in this format. So first of all, our set will contain, so for this example, it will contain 1, then it will contain 2, then it will contain 3. But whenever we are trying to put 1 again, it is not going to be uh, executed because set only and only uses the uh, only contains what say the unique elements, and then the size of the set is now 3. So size equals to 3 is now, and our length of the nums is 4. So 3 less than 4, it will always give us true. So that means our set, our array contains duplicate elements. We can solve this same problem in our previous approach. So what we need to do here is we are going to just check a criteria that if what was the condition? That is, if X in scene, that means X is present in our array, right? So if so the set dot contains num. If the condition is true, then we are just return true. Else we are adding this and we need to return. So let me add it a comment here and return false here. So it should work. Let me run it. Okay, so I need to wait 1 second because I need laptop into the charging mode. So as you can see that it runs successfully. Now let me submit it. Yes, the problem is successfully submitted. So this is how we successfully completed this problem, which is contains duplicate. Now in the next day, we are going to solve some other problems. Thank you very much for watching.